Okay, so we are now starting our next unit of chemical reactions. And in order to write a chemical reaction, which is like a sentence, we need the words. So we need to know how to write the names of chemical formulas. So this is a chart to break down how we will tackle chemical nomenclature. So we are going to be naming inorganic compounds, and those are ones that have a positive side and a negative side. And the first type we're going to look at are binary compounds. Bi meaning two parts, and they end in the suffix IDE. So we've got two elements that make up these types of compounds. The other type we're going to look at are polyatomic compounds, and the poly means many, and so there are many types of atoms that make up these compounds, and there is a negative ion that contains oxygen in part of it. So that's part of the polyatomic compound. So the first thing we're going to look at are ionic compounds. Ionic compounds. Ionic, as we looked at in chapter 2, are metals plus nonmetals. They have to have a metal and a nonmetal. So we will look at ones that are monovalent, mono meaning one charge, and multivalent, multi meaning more than one charge. And multivalent cation. The cation, remember, is the positive portion. So we will start with that in our notes. Okay, so flip to the part in your package. Oh, before we start, there's a number of reference sheets we will have, and we will need them at our disposal. So if you need to take them out of your package to do your work, that's advisable if it helps you. So that's just the other part of polyatomics we're going to look at. So these are a list of common radicals or polyatomic ions and their charges or valences. These are also the charges on various elements on the periodic table. Something else we will look at. You'll have that handy. You will also have other charges for the classical and stock systems when we name elements that have multiple valences or multiple charges. So that'll be another thing you'll need. You'll also have a periodic table at your disposal. So you'll use the one in the textbook for now. But this has also the charges on numerous polyatomic ions, some of which we will learn how to derive the names of them, meaning we will learn how to get the names. And on here, there also are some more multivalent ions, as well as we have the Latin system stem words. So for Fe, iron, we would call Fer, Cu, copper, be Cup, and so on and so forth. Okay, so you'll need those out with you to help you do these types of questions. So as I said, we're going to start with ionic monovalent cations to begin with. So, oh, just a second, I gotta let my dog out. Okay, so the first part of the name comes from the metal, and for that one we write the full name, and the second part comes from the nonmetal with the suffix IDE. So, for example, we will look at calcium nitride. So we will name, the first part of this name is calcium, and the second part is nitrogen. So we take off the bottom, the end of it, and oops, and we call that, and we name it nitride. I was saying nitrogen, but I meant to say we're changing nitrogen to nitride. This thing's not going to work for me. Oh, there we go. Nitride. Okay. Another example could be MgO. So the first name is magnesium. This is oxygen, and we would call it oxide. And to give us one more example, H2 as a gas is hydrogen. This is hydrogen. Okay? So these are some compounds. Actually, let's get rid of this hydrogen. We won't go use hydrogen. Instead, let's use KCl. So this would be potassium chloride. Okay? Because H2 is not ionic. All right, so next how do we write the chemical formula for these ionic compounds? So here are some steps. We write the symbols for the elements with the metal first and the non-metal second. We then refer to the periodic table to determine the ionic charge of the ions, and then we write the charges above the symbols. Then we use a table to determine the number of each type of ions that is required to bring the total charge to 0, called the zero-sum rule. We can also use the crisscross rule, which I will show you. And then we write the chemical formula with subscripts representing the number of each type of ion. Do not write the charge. Then we make sure the subscripts are the lowest whole number ratio and do not use a subscript of 1. So the first example we will look at is hydrogen sulfide. Hydrogen sulfide. So, step 1, we write the symbols. So hydrogen and sulfur. The charge on hydrogen is +1. The charge on sulfur is -2. So we cross those over and we end up with H2S as the formula. A second example would be sodium phosphide. So we write the symbols, Na with a charge of +1, and phosphorus with a charge of -3, and we cross over the numbers, and we end up with Na3P. And to do one more example, we have calcium oxide. So calcium has a charge of +2, oxygen has a charge of -2, and we cross them over. So we would end up with CaO, because remember when those are 2s, right, they cross out and they reduce to CaO. Okay, so how does this apply now to polyatomic ions? So in the case of polyatomic ions, we identify any polyatomic ions in the compound. So they don't really usually have an IDE ending, and they contain more than one element. So in this case here, oftentimes they have 3 or more elements, and so you look for brackets. And that would help you out to determine where the polyatomic ion is. So AlOH3. So we would name this aluminum. OH is the polyatomic ion. So we might know that one, or we might have to refer to our chart of polyatomic ions and find it. So I'm going to pull my chart out. Of course, I know it, but just to show you where you could find it. I would know the charge on this would be -1 because aluminum is a 3. So let's find hydroxide. And where is it? Somehow, oh, there it is, right there. OH with a charge of -1. Okay, there's our hydroxide. So this would be aluminum hydroxide. Okay, let's get another example. Let's try BaF. SO4. So we know that this is barium, so we would name it. And this part is sulfate. How do I know? Again, you have to refer to your chart to find SO4. So you look around to, and this is one you're gonna have to memorize, but SO4 is right there. So SO4 with a charge of -2. So barium I also know has a charge of +2 because there's no subscripts there, so I know it has to be balanced out. So this is barium sulfate. And let's do one more example. K3PO4. So I know this part's potassium, and this would be phosphate. So because these are not these numbers are not multivalent, these elements are not multivalent, we don't need a bracket in the middle indicating a charge. If they did have a charge, we would have to indicate that with a bracket. So that's not the case. So we don't need a bracket. Now, how do we write a formula for a polyatomic compound? So, same as above, using the polyatomic ion chart, unless it is one that you have to memorize. So for example, phosphate, sulfate, carbonate, chlorate, or nitrate. You have to know those ones. So we're same as above, meaning up here. So we have, if we were doing aluminum phosphate, we would have to write the symbols for the elements. Metal's always first with its charge on top, a +3. Phosphate is PO4 with a charge of -3. And then we cross those values over. So this is coming down here and this is going over here. So that gives us AlPO4. Because remember, the same number, so they cancel out. Okay? Another example would be lithium carbonate. So lithium is Li with a charge of +1. Carbonate is CO3 with a charge of -2. Again, we cross over the numbers. So that would be Li2CO3. Okay. So as I mentioned, you need to remember these 5 polyatomics. So that's PO4 with a charge of -3. Phosphate, SO4 with a charge of -2, sulfate, CO3 with a charge of -2, carbonate, ClO3 with a charge of -1, chlorate, and NO3 with a charge of -1, nitrate. Okay, so you need to learn those. In the next part, we will learn to deal with multivalent metals. So I'm going to pause the video now and start another video for the next section.